My name is Kim Hissong from the University Advancement Division here at St. Lawrence, and I will be helping to moderate tonight's lecture. We're very excited to offer this online Laurentian lecture series as a way for alumni, parents, and friends across the globe to experience today's St. Lawrence classroom firsthand. Tonight's lecture is our 12th in the series, and we look forward to many more to come. Before we get started, I'd like to cover just a few technical items that should help make your webinar experience a more enjoyable one. At various points throughout the lecture tonight, we will pause to invite your comments and questions. And at that time, you can virtually raise your hand using the hand icon that you should see in the navigation pane at the top right of your screen. The icon is a small hand in blue. Click it once to raise your hand, and when you're called on, you'll be unmuted and you can ask your question directly. Or if you prefer, you can type in your question or comment. A few tips about the webinar audio. If you're using the audio through your computer, please know that you must have a built-in microphone or an external microphone in order to ask questions. Otherwise, you'll be able to hear us, but unfortunately, we won't be able to hear you. If you're using your telephone audio, if you have your phone on speaker during the webinar, in order for us to hear your question, you'll likely need to take it off speaker during that time. During the presentation, we encourage you to minimize the navigation pane so you can see the full screen. Simply use the orange arrow at the top of the navigation pane to do that. And if you need to maximize the navigation pane at any time, just use the orange arrow again. So without further delay, I'm pleased to introduce our lecturer for the evening, Michael Schuckers, Associate Professor of Statistics. Dr. Schuckers earned his BA at Penn State in mathematics, an AM in statistics from the University of Michigan, and his PhD in statistics from Iowa State University. He joined the St. Lawrence faculty in 2002 and is the founding director of the Martha H. Class of '62 and Greg H. Peterson Quantitative Resource Center here at St. Lawrence. Dr. Schuckers also co-founded Statistical Sports Consulting, LLC, which develops data and decision-making tools to give their clients a competitive edge in all facets of their business, from recruiting and signing to game planning and in-game management. Dr. Schuckers' work in data analysis in the NHL in particular has recently been featured in the Boston Globe, Fox Sports Arizona, the Ottawa Citizen, and USA Hockey Magazine, to name just a few. Tonight's lecture is titled Modern Hockey Statistics, an Introduction. So I'm pleased to now turn it over to Dr. Schuckers.
Thanks, Kim, and good evening, everybody, or good night in some cases, I think, to some folks joining us. Thanks for that wonderful introduction, Kim. As always, whenever you talk about sports, it's important, I think, to give a little bit of background. So as Kim mentioned, I went to Penn State. I grew up in Pennsylvania. And so I grew up playing high school football and doing track. I had some opportunities to play college football and turn those down for an academic scholarship at Penn State. And it seems strange in this academic journey to end up doing sports. So a little bit of how I got to this point and how I ended up doing sports. I was a fairly sports-obsessed kid growing up. My dad had played football at Colgate and also actually lacrosse for a year at Colgate. And so grew up with a lot of sports. And when I went into academia at the time, academia was not particularly a place where sports was viewed as a particularly good area to go into and do research. I think that's changed in the last couple of years. We've now actually have some academic journals in sports statistics. I ended up actually doing a lot of research in biometric identification, fingerprints and iris scans, and actually in 2002 published a book on that work and decided I wanted to take a break from that and do something fun. And about that same time, my good friend Chris Wells, who's the women's hockey coach here at St. Lawrence, was kind of tugging at my sleeve saying, hey, come on and take a look at some of this hockey stuff. And I have 3 kids, but 2 of them play hockey, or 2 of them played hockey. My oldest has decided to move to track rather than hockey for his winter sport. And so I said, yep, I'm going to forget about biometrics for a little while, take a break, enjoy this, and started doing sports, and it's pretty much become all I do in terms of my scholarship. So that's a little bit of background on me and my interests. Yeah, let's go ahead and get started. So one of the things I think that is often, and I probably don't have to mention it in this college-educated crowd, but sometimes that we get a distinction between what is statistics, as in a statistic, as in the unemployment rate, or a single observation, how many students are going to enroll in the fall, and the branch of academic statistics where we're really trying to study this process of how do I glean information out of a data set? How do I collect it in a good way? How do I analyze it and present it so that we can extract some good information? Over the last 10 years, we've seen the addition of this word analytics, I guess, to the vocabulary of this area. And I think it really is to distinguish sort of the 2 meanings that we have for the word statistic in English, or statistics. And it really is to sort of, I think, highlight sort of this extract meaning from the data that we have. And so throughout the evening, I'm going to refer to hockey statistics and hockey analytics. In all that time, I'm going to really refer to this last meaning that I have there in terms of we're trying to extract some usable information from the data. So as I mentioned, in this talk, we're going to talk some hockey statistics. I'm going to talk about some of the new statistics that are being utilized, particularly in the NHL, and then talk about some of the ways that we can get at some of this information and some analytics. So some new small s statistics that are out there and being used, and then also sort of the process and the information here. And there's that gleaned word I seem to like and use in terms of extracting. Where possible, I'm going to throw out some of my own work and talk about it. Really, and I can happily share this, but there has been over the last 10 years a community that has developed in terms of, and it has primarily been an online community of folks doing blogs and sharing, and it's now moved to Twitter, where folks are communicating and trying to get at and use the data, the limited data that we have there to extract and to share information. So yeah, just talking about where things are in terms of sort of a Moneyball sort of thing, hockey is behind. It is certainly not where baseball is, or basketball or football, and football there both meaning European soccer and American football. This past summer, we saw something that has been dubbed the Summer of Analytics in hockey, and that primarily started a little over a year ago with New Jersey putting out an actual ad. Those who know New Jersey at all, it's kind of strange because they're not an organization that necessarily shares a lot of information, but they put out a public ad. Prior to that, some of the teams that had been using analytics were teams that had been doing it very quietly, very hush-hush. Obviously, there's potentially competitive advantage going on there. But last summer, with New Jersey putting an ad out, we saw the 6 teams that I've got listed there made some high-profile hires from folks from the analytics community. And so we've seen that lead to somewhat of an embrace, or at least the beginning of an embrace, of analytics at the NHL. I believe it's mentioned later on, but the NHL itself has added some of the things that we'll talk about tonight to their website. They did that at the end of February, so that's a fairly recent thing, and they are referring to what they've added as enhanced statistics. And here are some of the other teams that have been involved. We know that Chicago and Los Angeles and Tampa Bay were involved prior to the Summer of Analytics. I think Nashville and San Jose a little bit less open about what they've done, but I think conceivably they have been doing this for quite some time. So just talking about hockey as something that is different from other sports in how we go about and how we think about analyzing it, it becomes difficult because unlike baseball, it is not a very static thing. In baseball, we have very specific events, very specific nuggets of data where we have a pitch versus a batter. Whereas in hockey, we have, as I put on the slide, very fluid. We have action going all the time. We don't have stoppages. We have players coming on and off without play stopping. And so this makes for some challenges in terms of data analysis. You have players that have got there about 40 seconds for a shift, potentially. You have penalties that result in a player or a team being without a player for a length of time, but they can return. Unlike, for example, soccer, where you have a penalized player and they're gone for the rest of the game. Overtime in the NHL is played a little bit differently than the rest of the game right now. There's some talk of making changes to that for next year. And then if we're tied at the end of an overtime, then we have a shootout. And that is in place in the regular season. Doesn't necessarily happen in other sports in a regular season, though you could think of some of the things that go on, say, in college football as a shootout, sort of a back and forth, each team getting a chance to score. So some terms, again, probably for a St. Lawrence crowd, I don't have to do too much of this, but we'll go through and talk about it a little bit. So even strength is when we have both teams having 5 players on the ice. I've got a map of the ice there in the upper right-hand corner of the slide. We generally think of a scoring chance as coming from that yellow shaded region, sometimes called home plate, sometimes called a grade A chance, but generally we're going to call that a scoring chance. And we think of that as a place where you have a higher probability for goals to occur. Power play, when you have more players on the ice than your opponents. If you're on the opposite end, that's a penalty kill, or you're being shorthanded, so you have fewer players. The offensive zone being the third of the ice closest to the opponent's goalie, your defensive zone closest to your own goalie, and neutral ice, roughly, they're not exactly thirds, but roughly the center third of the ice. We're going to talk about points. There are 2 types of points, and we'll mostly focus on team points. In the NHL currently, it's 2 points for a win, 1 for a loss in overtime, and that would also include the shootout, and then 0 points for a regulation loss. For players, generally, think of a point for a goal or an assist. We'll talk about save percentage. That's the percentage of shots faced that are not goals. And a shooting percentage is percentage of shots taken that are goals. And I'm going to make some reference, because most of the data that analytics people such as myself use comes from the NHL's real-time scoring system. And this was a system put in place sometime in the 2000s to record events and their location, as well as who was on the ice. And I've given a list of some of those events. So shots are recorded. A missed shot, that's a shot that's viewed as an attempted shot, but which misses the net. Hits are recorded. A block shot, again, it's an attempted shot that gets blocked, is recorded. Face-offs are recorded. Giveaways and takeaways are recorded. I've got the 4-letter shorthand that the RTSS uses for give and take there. Stoppages are recorded, end of periods, etc. Just note the process that we have there. In general, at any particular game, any particular night, you have 6 people, some combination of whom are shouting out events and some of whom are typing into computers to record the events that you have. That is a somewhat imperfect system, and we'll talk about some of the things that are coming down the line that are likely to replace it. So there's the RTSS system. So first thing that I want to talk about in terms of things that we know and that we've learned is the idea of what is a goal worth. So what we have here is a graph of goal differential. This is, I believe, 5 or 6 NHL seasons, I believe through 2012, if memory serves. And what we have is team points on the y-axis. And the red line there, its equation, this is a intro stats sort of linear regression line of best fit here. And so the predicted number of points would be 91.6 plus 0.33 times the goal differential. And this is a fairly strong relationship. We've got a correlation here of 0.94. So a very, very strong relationship, one that we've seen repeated year after year there. And so the things that we can get out of this are, well, I'm going to try and turn this into what is a goal worth in terms of a win. And then we're also going to talk in terms of monetarily, what does that mean roughly? So what is a goal worth using goal differential? I'm going to use GD for goal differential. So in terms of wins, what we're saying for each additional goal differential, I'm getting 1/3 of a point, roughly. That means that 3 goal differentials is going to equal 1 team point. So then 6 goal differentials means 2 points, means a win. One way to think of this is you're in some game in the 3rd period and you get an extra goal. And about maybe 2 or 3 out of those 6 times, right, that you're already ahead, so that goal isn't going to matter. And maybe another 2 of those times, you get that goal, but you're already behind enough, so that goal doesn't matter. But about 1 of those 6 times, that goal is the goal that moves you from a tie to a win. And so that's the idea there of the 6 goal differentials being roughly 2 points or a win. In terms of dollars, I've got a link there, and some other work has been done on roughly what does a win cost in the NHL. So in the NHL, we've got a salary cap. The idea here in terms of getting this slope is we're looking at the roughly what you would expect for a team salary, and those numbers were done in 2010-11, so some changes need to be made there and a little bit of update. But the link there is where the first idea for this paper came from. So 59.4 roughly is average salary cap. That's probably a little bit higher now. 12.3 would be what you would have to pay as a bare minimum to have basically minor league players playing in the NHL. You look at that over the average number of points, roughly 91, versus some estimate there of the 52 being how many points you would expect a team of sort of replacement level players or minor league level players obtaining. Buffalo sort of is pushing the envelope there of that of late. And so what we end up there with is about $1.2 million per point. That means that each goal then is worth about $400,000, and that each win based upon goal differential is worth about $2.4 million. Probably there's been some changes in terms of the collective bargaining agreement, and so I might argue that that number has gone up and down a little bit in the last couple of years since this analysis was done in 2010-11, but it's probably not far off in terms of what we're seeing. So goals, right, it's going to take us 6 goals over the course of 82 games in a season to get us an extra win, and it's going to cost us as a team about $2.4 million for an extra win. So the next topic that I want to talk about is one that really received, a good bit of attention, and this is what are called Corsi and Fenwick numbers. And I'll have to apologize. Hockey analytics folks don't have great names for a lot of their metrics. So the Corsi number is named after Jim Corsi, who used to be the goaltending coach in Buffalo. And if you read Bob McKenzie's book, it's somewhat related to Jim Corsi, but Corsi sounded better as a name for something. But it essentially is for a player when they're on the ice, or for a team, you count the goals that occur, the shots that occur, the missed shots, and the block shots. So that would give you a Corsi number, and then you count all of those for both teams when you're on the ice, and what percent do you get of all of them. So a good Corsi percent for a player would be 55 or 60%. That is, when their team is on the ice, they are getting 55 or 60% of the goals, shots, missed shots, and block shots. Fenwick is essentially the same idea, but it takes out block shots, with the idea being that some teams are going to be much more aggressive about blocking shots than others. And so, and again, here we have one of these crazy names. Fenwick is named for Matt Fenwick, who was a blogger who sort of suggested this might be a reasonable thing to do. And so the Fenwick percentage, again, being what percentage of the Fenwick events are happening for your team out of all of the total while you're on the ice. When the NHL added these to its website, it's replaced Corsi with shots attempted, and it's replaced Fenwick with unblocked shots attempted, so SAT and USAT. And there I've got a link describing that. It will be interesting, mostly from an archaeological perspective, to see how much those names take hold. I will probably call them Corsi and Fenwick, though I'll try to call them shots attempted and unblocked shots attempted. But I've been calling them Corsi and Fenwick for 10 years, so it's going to take a little bit of time. Go ahead. So the question comes up, why do we care very much about these numbers? Why do we care about Corsi, Fenwick, the shots attempted, unblocked shots attempted? So it turns out through a lot of work and a lot of analysis that if we look at these two percentages, and in particular we look at them when games are close. So we know, for example, that teams that are up by 2 or 3 goals play a different style of hockey in the NHL than the style that's played when games are close. So I'm going to call a game that's close one where the goal margin is, it's either tied or it's a 1-goal differential. That this Corsi percent and the Fenwick percent correlate with future win percentage. They correlate with future goal scoring rates. And so essentially these are good predictors of future performance. And as I think I'll mention later, they're better predictors of future performance than goal percentage or shot percentage. And so adding the additional information there creates better predictors. And then the other things that we know is that Corsi numbers, Fenwick numbers tend to be correlated pretty strongly with scoring chances. And so those folks who have actually looked at scoring chances, and most of that has been by hand, is that they correlate pretty well with those. Corsi and Fenwick tend to get called possession metrics. That is, they are thought in some sense to be proxies for what percentage of the time does a team have control of the puck. That is, so a little bit of background, the NHL for sometime in the late 90s actually tracked percentage of possession time in each team's offensive zone. They stopped doing that for no one knows what reason, but they stopped. And so we don't have that. What we do have is a small number of studies suggesting that Corsi and Fenwick may be good proxies for possession. I think that's a little bit, maybe a little bit sloppy of the analytics community to refer to them as possession based upon a small number of studies. But if you go and you read ESPN or you read TSN, Sportsnet, you're going to see them referred to as possession numbers or possession statistics. So one thing I wanted to do is talk about this sort of ability to predict future performance. And so here we have, this is last season, regular season. This is the Fenwick percentage close, again, within a goal. The LA Kings finished 6th in the West. So just quickly on this table, we have the rank order by Fenwick percentage for each team, some teams here, and where they finished in the standings during the regular season, and then where they finished overall. And so we see the Kings at the top, but the Kings finished 6th in the West. Chicago 2nd, but they actually finished 5th in the West. San Jose 4th, Boston 1st in the East. New Jersey actually 10th in the East, and we'll come back and talk about them in a little bit. But you notice that the teams that were finishing higher in Fenwick are actually doing better in the Stanley Cup than we would expect them to do based upon the regular season standings. And so that's one of the things that the analytics community has been able to say is, look, your standings are not necessarily as good a predictor of future performance as something like Fenwick. So, notice that Pittsburgh, who was 2nd in the East, ends up losing in the 2nd round. And so they were 15th in Fenwick. Whereas the top 2 teams there, Chicago and Los Angeles, going very, very far in the playoffs. New Jersey, just make a mention, we'll probably come back and talk about the shootout a little bit later. New Jersey, their regular season standings of 10th in the East, they probably would have been 5th or 6th if they had won at least one shootout, but they lost all 13 shootouts during the regular season, and so their standings were quite low. And my next slide is just this year, to give you an idea of some teams that are doing well this year. So the Islanders have made, from the view of the analytics community, quite a few good trades. And one of the outcomes for that analytically is that they have bumped up their Fenwick percentage here. Tampa Bay, Winnipeg, Pittsburgh has made a couple of trades, and they've moved themselves into a different place. Though Pittsburgh, they're committing more penalties than anyone else in the league, and I think that may have an impact on them in terms of regular season standings. Again, Chicago and LA and Boston, all teams that are doing pretty well, but obviously not as well as they had done last year. Ottawa I've thrown in there for some local flavor, and Buffalo as well. So maybe even historically bad Buffalo at this point. So again, the idea of Fenwick and the idea that this is possession, I just wanted to take a look and go ahead and Kim, if you can show that video. So this is a game from May 10th, 2013.
Kraft is searching for America's most passionate hockey community.
Good. Yeah, we got Kraft, which is important. To pay the bills.
Game, plus $150,000 in arena upgrades. Up your community score at CraftHockeyville.com. Kraft Hockeyville, for the love of hockey.
Wind up. Yeah, I'm going to have Kim pause it. I just want to, so I believe this is a Stanley Cup playoff game. In the third period here, this is Boston-Toronto. I believe the score is 2-0 Toronto, and I'm sorry for the Boston fans here. It goes well, but the game doesn't end well here. And we're going to look at, for now, just want you to pay attention to, this is what happens with possession.
Shooting position, he leads all of the Bruins with 6 shots on goal. There's the Leafs wingers getting into the action, but they couldn't get the puck up. Morton slammed against the boards by Dion Phaneuf. Trying to pin it there. Gunnarsson coming over to help, and he's lost his Lucic, and back to save today, perhaps, his Bozak. Kuhlman against the pinching Chara. Finally, the puck comes loose, and Lucic knocks it along the boards to Krejci. Bozak's after him and knocks him down. From his knees, he's back up again. Krejci, Morton. Painted into the corner by Carl Gunnarsson. Finally, Gunnarsson with some time. What's he going to do? Stays right there. Lucic, checked by Phaneuf. Goes to the basket over there in the corner. Down to the boards, another pitch here by Seidenberg, and he holds the lead in. Lucic up against Phaneuf. Gets to the corner, throws the puck back. Chara with the shot, right in the corner, the rebound. Horton can't get tied up by Bozak. Chara again, Seidenberg. And but he got the puck into the corner. That's why he needed to be stopped. This line needs to change. Chara fires, tipped into the corner. Here comes Seidenberg up against Grabowski. Kept the puck in. Krejci, Chara.
So that's a fairly unusual sequence there in the NHL. We have about almost 90 seconds of possession where Boston keeps possession the whole time, eventually ending up in a goal. And so again, the idea here, Fenwick and Corsi, in some sense, is a proxy per possession. Boston getting 2 or 3 shots in there. But again, they're having possession, but it is not completely measured by the sorts of things that we're after, or at least the sorts of things that we've been looking at. And so the possession there, not perfect, and we'll also talk about some of the data from that sequence in a little bit. The next idea that I want to talk about is PDO, and again, another name that the hockey analytics community has picked that doesn't have much meaning. We think it's the initials of someone who was posting online, but we're not quite sure. And the NHL has changed it up, and we'll see some of that. So the idea here is that you take a team save percentage plus their shooting percentage. And in the NHL, they've made it shooting plus save percentage, so SPSV percent. Doesn't quite roll off the tongue like PDO. And the idea here is that a team's save percentage tends to regress towards the league average save percentage, and also towards the goalie's career save percentage. And so we'll talk about that. The same thing is that a team's shooting percentage will also tend to regress towards the league mean. And so the idea is, in some sense, because both of these quantities together are sort of headed back towards the mean, so that as we see differences from the league mean in this quantity, we're expecting them to sort of congregate in the future back towards the mean. That they're generally considered measures of luck, so that if we see a team with a high save percentage for a period of time, say a Ottawa of late, that we would expect that future performance would be much closer to a league average. And the next slide here is talking a little bit about the idea of regression to the mean. Note it's a slightly different idea than the regression line that we talked about earlier, but the concepts are actually related. And here's the idea is that extreme values tend to be more similar to averages over time. And big picture, we think about any results that we have in statistics as some measure of skill and some measure of randomness. And so we get outcomes that are a consequence of both. And if we see things that are very high or very low, we recognize that those are going to be due to both skill and luck, but that over time, the luck parts of those are going to tend to bring us back. And so we think that the luck and the chance will even out, and we will head back towards the mean for those extreme values. And often we think of things like a sophomore jinx. Back when I was a little kid, there was a Sports Illustrated cover jinx. I don't know if kids still have that today. But the idea that you would be on the cover of Sports Illustrated for having a great 2 weeks, and then the idea was always, oh, well, it was because you made the cover of Sports Illustrated, you weren't keeping your eye on the ball anymore or eye on the puck, and you were going to have a drop-off. And as statisticians, we tend to say, yeah, it's more likely that things are just going to trend back towards the mean over time. The same sort of thing you have as a sophomore jinx, that someone in their first year, usually a rookie, this going back to baseball a little bit, but a rookie performs better than anyone expected, particularly well. Then in their second year, they don't perform as well, and there's all the stories of, oh, the league catches up to him, everybody's figured him out. In some sense, it's just the luck catching up, and we tend to have results closer to the mean, which would be more in line with what we would have expected. So the classic PDO example is actually two of them that come from 2010-11 in the analytics community. So in the previous season, Dallas, who I believe here is the red line, had finished 12th in the West. But in January of 2011, which would be somewhere near the left-hand side of our graph, Dallas found themselves in third place. Actually, probably more towards the second or third vertical bar there. Dallas found themselves in third place. And at that same time, New Jersey found themselves in 15th. And New Jersey, the blue line at the bottom, again, we see both of those lines converging back towards 1,000. So a PDO, again, adding a save percentage and a shooting percentage together to get roughly 1,000 is what we would expect. And of course, you can go back and look at all of the wonderful stories about how Dallas had made great coaching changes, great decisions, all of these wonderful stories, right, about all the smart things Dallas had done, all the good trades. And then slowly their luck runs out over the rest of the season. They end up finishing in 9th place and out of the playoffs. And so there's a link to a much longer article that goes through and describes this if you'd like to take a look. But again, it's sort of the classic, we see a team riding high in the middle of the season, all sorts of great things that we're hearing about them, and their luck is eventually runs out. So in that same vein, here are the folks from last season who had particularly high and particularly low. I'll get it right. Shooting plus save percentages. And so the teams with particularly high, and we think of teams, if a team is above 100 or below 99, we think of them as sort of outside of the range of what we would expect there. And so you can see the top teams there ended up losing. I mean, Boston being the 1 seed, Anaheim being the 1 seed, and both losing in the second round. So in some sense, maybe sort of outperforming what we would have expected of them, and that coming back to haunt them. We saw Montreal, Detroit, Tampa Bay. Tampa Bay is maybe a special case because their goaltender got hurt just before the playoffs started. But again, they still lose and still were a team that was somewhat lucky. And then the bottom there, the unlucky ones from last season, yeah. There, and then let's take a look at next slide, which is this year. And so some teams that possibly are going to see have some downfall. there, the Rangers in New Jersey, Pittsburgh, Nashville, St. Louis, Montreal at the top of the teams that we might expect to see some decline. And then at the bottom, I've actually listed a couple of teams that are right in line with what we would expect in terms of Winnipeg and Chicago and Los Angeles. Buffalo, even there, they're 16th in the East as of this past weekend. They're getting a little bit lucky in terms of that, in terms of their shooting and their save percentage. A lot of this come back to why do we like using these measures. They are certainly not perfect measures by any stretch, but we do find them to be predictors that are good predictors of future performance and better than goal percentage, better than the percentage of shots on net, better than winning percentage, and that we found these to be, as a community, we found these to be robust. They show up over multiple years and multiple circumstances, regardless of what are the teams that are involved there. And the same is true. With PDO. So that gives you a sense for some of what's going on. There are some pieces that are missing, right? And there's some ongoing work trying to incorporate some of, the following things that we've got listed here into the analysis. So one of the big ones, and we'll come back and talk about this, is shot quality, which is sort of the average shot probability for a particular goal, for a particular team, with the idea being that for the analytics community, if looking at a team, say a team's defense and for the shots that they've given up, it tends to average out over the course of a season. And so there is not much difference in average shot quality over the course of a season. And so while shot quality matters a good deal in an individual game, it doesn't seem to matter much in terms of the course of a season and predicting future outcomes. Penalties are one that I think has been a bit overlooked and is a place where the penalty information could be used. We do know that players who tend to draw penalties, that tends to be something that you can predict in the future. Quality of your power play, quality of penalty kill, quality of goaltending, these things are probably things that have small effects, but are not having the big effects that, say, a Fenwick or a PDO are. Shooting percentage would also go along with shot quality from an offensive perspective. So I mentioned the sports narrative as it related to Dallas and PDO here. So our results are some combination of skill and luck, or a statistician might say randomness. This is an opportunity to open up to some questions. So this is a nice spot to take a break and talk about some of the things that, some of the questions that you might have.
Okay, great. Again, just as a reminder, if you have a question or comment, you can either use the hand icon to raise your hand if you'd like to ask your question aloud, or if you feel more comfortable, you can also type in your question or comment. So it looks like Rajiv has a question that he would like to ask. So Rajiv, go ahead.
Hello, can you hear me?
Yes.
Yep.
Oh, so I was going to ask if we have a Fenwick percentage for SLU hockey team.
It's a great question. One of the things I think that if we have 6 people at the NHL, we probably have 1, maybe 2 for the SLU team, and so we may have that for our own team. We don't necessarily have and trust results from other teams to make something that is comparable. And so generally, because there are big differences from rink to rink in college hockey in terms of of what is recorded. Haven't really had a lot of people investigate or look at something like Fenwick at the college level.
Great. Here's just a comment from Bruce Carlisle. It says that you should use the video of the Gavin Bayreuther tying goal in Lake Placid to demo this point. Not quite as long, but plenty of possession and shots.
Yeah, no, that's a great comment. And it's also one that's good to illustrate pulling the goalie, which, depending on time, we can get a chance and we can talk about in a little bit.
A question from Tom Moore. He says, has anyone used a data mining approach to develop better metrics?
Yeah, so we are starting to see the beginnings of some things that are more sophisticated. And I'm going to talk about what might be more sophisticated, more data mining sorts of things. While it's not well known, I think that there are some things out there that actually do better than Fenwick and Corsi, and they are based on using more sophisticated approaches. I would say Brian McDonald, who used to be a professor of mathematics at West Point and who was hired by the Florida Panthers last summer, would be somebody who's developed some of that sort of work.
Okay, another question here from Eric. He says, what is the best time in the game to pull the goalie down one goal?
Down one goal. So I'll answer the question, and then I think we can come back to it because it's one of the topics that I want to get to a little bit later on. But generally, if what you're trying to do is optimize the chance of outscoring your opponent, not necessarily of scoring first, but actually somewhere around 3 minutes turns out to be optimal, even though what it generally happens at the NHL level is about 1 minute or maybe a minute and a half. But I will just add that Chris Wells, who's our women's coach, has led the nation for the last 7 or 8 years in minutes with the goalie pulled, I think in part with some conversation. So I think he was doing it before we had a lot of conversations, but in part because he's read this sort of thing.
Okay, we've got another question from Bruce. So do the NHL GMs using this recognize that the way certain players are utilized can impact their Corsis? For example, a fourth liner who takes most face-offs in defensive zone, wouldn't he have an artificially depressed Corsi?
That is such a great question and totally leads into something we're going to talk about. One of the things that analytics folks talk about is something called a zone start, which is effectively where does your shift start. So as the questioner pointed out, if someone is starting in their defensive zone, they're less likely to have good outcomes, and we can actually quantify differences between starting a shift in your offensive zone versus starting a shift in your defensive zone. And we can, and I have, built models that will adjust for those factors.
It looks like we have a question from Jordan Paley. Jordan, go ahead and ask your question.
Yes, I was wondering, is there a difference between the analytics between like the first line of an NHL team and a fourth line, because the first line is usually used as a skill position and the fourth line is usually used as a checking line?
So there are certainly differences in the outcomes that we would expect to get from those two lines. And certainly we can see some of those, and we'll talk about some of those. I think more and more what teams are coming to do is recognize that the importance of those fourth lines for maintaining, or not necessarily being checking lines so much as maintaining possession lines. And as something that is something that has been utilized. For example, I think a good number of the moves that Pittsburgh has been making has really been to sort of strengthen the quality of what they're seeing on their third and fourth lines, recognizing that they've had quality on their first and second lines for many years.
Great. We'll take one more question. This one's coming from Seth Jackson. He says, will you be discussing defense-independent goalie rating at all? From a Cam Talbot fan.
So I do have a slide on the goalie rating that that the questioner, that Seth mentions there, and we will talk about it. I don't have results from this season, so that probably makes a Cam Talbot fan not particularly happy that I won't have results for that.
Oh, and we actually have one more from George Hughes. He's saying, how do you think an Olympic ice sheet may impact Fenwick?
That's a great question. I don't have any data on that, and so as a statistician, I always like to fall back on data. But I would suspect that it probably would lead to a higher importance of Fenwick. That you generally, the thought is that you have a more open game with the Olympic ice, and therefore, yeah, you're going to see a higher impact of Fenwick. That's a hunch and not necessarily any data.
And this one is from Mike McKenna, and he's saying, can you keep the goalie rating slide confidential unless some guy named Mike McKenna is featured really high on it?
So if we make the data set 2 or 3 games from Columbus, we can probably get that to work. Yeah, no, that's a great question, and maybe fortunately for all, we talk about the method, but there's not a whole lot of details on results, at least on that slide.
So we'll come back to more questions in a little bit.
Okay, we're going to get now into a little bit more analytical viewpoint and get to some of the more analytic things. So from a statistician's perspective, we really think of hockey as a binomial game, right? It comes down to goal or no goal, 0 or 1. And in a binomial sense, statistically, N and P, N being the number of shots you take and P being the probability of those shots going in, is important. If we make M and R what our opponents do, then we can think of goal differential as this, I might call it a lovely equation, but this equation where you have EV for even strength and PP power play and SH for shorthanded. And we could build models for dealing with this sort of thing, but that's just a sort of a framework for thinking about it. Yeah, I guess I mentioned shot quality a little bit, and I'll talk here. So in terms of this, thinking of things as this goal differential, Corsi and Fenwick really are predictors of future ends, right? That they're saying if you get shots and attempted shots off now, you're more likely to get shots later. And I think the open question is, can we drive up or change those proportions, or can we drive down our opponent's proportions? And I think that a big part of this is lack of quality data. One of the things that we have right now, or one of the only things we have in terms of shots right now, is the X and Y locations. We have the type of shot. We don't, for example, have information on whether or not the goalie is screened, which is a big factor in terms of probability of whether a shot goes in. We don't have any information on, is this a third line D taking the shot, or is it Chara taking the shot? We know it's Chara taking the shot, and we know that has a small impact, but we can't necessarily quantify it in terms of the speed of the shot and those sorts of things. And so there's been a bit of a debate among the analytics community in terms of how much impact is there in terms of shot quality? And here, yeah, as I mentioned, it's a big debate. If I define shot quality as sort of the average shooting percentage, either that's for or against, the debate is really, does it matter some or a very, very little? We know that defensemen have lower shooting percentages, forwards have higher shooting percentages. We know that the team shooting percentage will regress. Individual shooting percentage regresses, but more slowly. And so certainly we can look at 2 or 3 years and say, it's clear Sidney Crosby shoots at a higher rate than the league average. But being able to tease that out of one season's worth of data can be difficult. And this is where I interject that the NHL, the data quality is tough. The X and Y coordinates are often far from what we might call ground truth in terms of video analysis. So we mentioned Cam Talbot, but this turns out to be especially true in some rinks. In Madison Square Garden, shots seem to be taken a little bit closer to or they seem to be recorded closer to the goalie than they're generally taken. There are a couple of other rinks that have some other peculiarities. There's clearly some biases in takeaways and giveaways and how those are handed out. Some inconsistency in rinks from what is a hit. And so all of that makes us hope that we can get a better quality of data, because I think one of the challenges in terms of getting analytics adopted more widely in hockey has been this perspective that the quality of the data just isn't there to justify the conclusions that we're getting, that there's so much noise in the data that it's problematic. We're somewhat hopeful that video tracking is coming, much like basketball. So in the NBA, each arena now has 6 cameras, and those 6 cameras record the location of every player, their X, their Y, and their Z relative to the surface, and of the ball, and they do that 25 times per second. And that your challenges then become too much data, but that's in some ways a nice problem to have. The NHL, in the course of the All-Star game this year, started using some video tracking, and they put RFID chips in the puck and in the player jerseys. And so the next thing we're going to take a look at is a quick little video of some of that.
The NHL is trying out a whole bunch of technology that we're going to see more and more over the years. And I know Mac is a big fan of analytics. Yep. Right, Mac? But you know what? The numbers they're going to start being able to access are going to be a lot more useful in a lot of ways. Right now, you know, things like speed. I know Glenn Healy loves this stuff where he can measure how far a player is away. They might be able to measure how long a flip pass is, for example, that a player is able to retrieve down the ice. So, you know, we're seeing the beginning of it for the NHL, and I think it's really interesting that they've embraced it. You know, before now it's really been bloggers and all kinds of people that have been really into the analytics stuff, but now the NHL is saying, no, we want to be in on that.
We're taking it over, what they're doing. And you know what? There's some great information that we saw demonstrated, explained to us.
Yeah, so that's just a quick demo, and you could see some of the potential that is there. It's certainly not going to happen, I think, anytime in the next, certainly in the next 18 months, but I think down the road it's a possibility. Sticking with some of these data issues, just point out, yeah, go ahead, the next slide. Yeah, this is from a blog, a Montreal Canadiens blog, and the arrows there are the differences between what was recorded by the NHL and what somebody sitting down and doing frame-by-frame analysis took to be the location of the actual shots that occurred. I didn't make a particularly nice graphic there, not too many rectangular rinks, but you can see the idea there of we have some of those data issues. Just to give you an idea of the sort of data that we're dealing with, this is actually one of the play-by-play files that we use, and this is actually the play-by-play file for the shot that we saw earlier, I should say the clip that we saw earlier of Boston and Toronto playing. And the sort of information that we have here, we know what is the event number, so 326 in the upper left is the 326th event. It occurred with 10 minutes and 11 seconds left in the third period. It was a face-off at even strength. Boston won in their offensive zone, and Krejci beat Bozak for that face-off. And so you have face-off, hit, giveaway, hit, shot, block shot, goal. Now notice at no time in there is there a mention of the change of possession, right? At least once in that sequence, Toronto takes possession back of the puck and then gives it up to Boston, all staying in Boston's offensive zone. And so that's not recorded. And so the granularity of what we have, looks more like this. I mean, we have, 7 events there over maybe about 70 seconds. And so you're not getting perfect detail of what's going on in the game. Interject continues here. The data quality is something we worry about. It's something we worry about in statistics all the time, whether it's hockey or otherwise. We think and we hope that things are correctable. I wrote a paper with Brian McDonald, who I mentioned earlier, where we tried to look at the different rinks and tried to adjust for the rates at which, for example, missed shots were called in each rink. And we found that a handful of rinks had rates that were higher or lower than league average. And we made and allowed for some adjustments, and it would allow for some reweighting. In terms of the XY coordinates, there's a little bit of work that's been done, and part of it is in a paper we'll talk about in a little bit that I did with Jim Kiro, and that was his senior project, and actually a SLU fellow, so a summer research project back in 2012, and then we finished that in 2013, trying to deal with that, and as I mentioned, the video tracking potentially coming. So just a recap of what we have seen. So we've seen value of a goal. We've talked about Corsi and Fenwick and their ability to predict, and we've talked about PDO, shooting plus save percentage being a measurement of luck, and that average shot quality can be a small factor. I think the more data that we get, we may see that it's an even bigger factor. Not unlike what happened in baseball, where defensive metrics were not highly valued, but once we had better ability to measure them, we saw some value in defense. So I want to move a little bit to player evaluation, because everything we've talked about so far has been at the team level. And Corsi and Fenwick were designed to be used at the team level. When we look at them in terms of player evaluations, we've got something that we call the Corsi relative percentage, so Corsi rel percent, and that is your Corsi percent when you're on the ice with a team minus your team's percentage when you're off the ice. And so that tells you how much are you doing better than your teammates. And I think this is, I've called it conventional wisdom, I think this is the most common, maybe enhanced metric that is being used for evaluating players. And just to give you a sense, Erik Karlsson, defenseman, fabulous defenseman for the Ottawa Senators. This season, he's had a Corsi relative percentage of about 3.6%. So that when he's on the ice, the percentage of Corsi events that his team has goes up by about 3.6%. And again, that's, even strength with a close score. So here are the top, I think I've got 10 players here at Corsi relative percentage. This is going back to last year. And one of the issues, we mentioned some of the context, but we have a couple of players here from the same team. So we've got Backlund and Giordano and Brody all from Calgary. Giordano and Brody are on the ice about 2/3 of the time that they're on the ice, they're together. So one thing that is hard to do is hard to extract who is really causing this jump in Corsi relative percentage. And actually Brody is, Giordano and Backlund are on the ice about 40% of the time together, and Giordano and Brody are on the ice about 65% of the time together. And so that's one of these things that contextually is I think hard to evaluate. From a statistical perspective, we'll talk about some of the ways that we can get at that and deal with those and make those sort of adjustments. Here we have this year. We see a lot of the same players. Just note, again, we've got 2 players from Boston, Bergeron and Marchand, and they're playing this year about 75% of the time together. And I think most of the analytics folks would probably say it's Bergeron who's leading that charge and having an influence on Marchand, but it is hard at this sort of level to be able to extract that sort of information. So we said the context matters quite a bit, and so here are some of the factors that folks have studied and again have found in study after study that these sort of things keep coming up again. And so where your shift starts is referred to as a zone start. And really, we'll mention this earlier, but if we move from starting in your neutral zone to starting in your offensive zone, that is like taking one of your average line mates and replacing them with a top tier line mate. So you can imagine taking a third line center and replacing them with Taze or Crosby is the sort of outcomes you get moving from a neutral zone start to an offensive zone start. Who is with them on the ice, right? If you're out there with Bergeron, that's going to have a big impact on the sort of outcomes that you're going to see. The same who you're going against. Going against a Taze, a Bergeron, a Datsuk, that's going to have an impact on the sorts of outcomes that you're going to get. The current score, we've mentioned looking at things when games are close, but those score effects definitely have an impact. Teams play different with a lead. Teams that are ahead, actually it should be the teams that are ahead get worse outcomes. And the thing is, we think that they're playing a less risky style. They don't get as good outcomes. And in particular, we see that the effects there, if those effects are occurring in the third period, we're seeing those events, I guess, extend and strengthen. And then whether you're at home or away, for whatever reason, and there's a long piece on home versus away in a book called Scorecasting, which looks at some sports analytics. But teams get better events just by being at home, whether that's comfort, whether that's the crowd, whatever that is, we get some slightly better events there. So I would say that the conventional wisdom analytics, how do we deal with and make these adjustments, is not perfect. And so you'll see this graph that we have on the right here is a graph from March of this year, actually March 16th. And each bubble represents a different defenseman. I don't want to get into much detail other than mention what analytics folks are trying to do is sort of tease out value here from this graphical tool. And it is a nice graphical tool, and there's a lot of information there. X-axis percent of zone starts, Y-axis quality of competition. Size of the bubble is how much time you're on the ice. Color is the Corsi relative percent that you get. And Corsi tends to be preferred to Fenwick by most people based upon sample size. Go ahead. And so this is where I interject, and I've got a nice slide, but really it's all about this is where statisticians start to make their money and we start to get some value, is we can actually add in and deal with some of these contextual factors. So next slide has the worst maybe you'll see tonight is a regression equation. And so I'm going to describe some regression-based methods here. And this is just Y is our outcome. If you've taken a course, you've probably seen it as a response or a dependent variable. All of those X's are independent variables, whether they are, as we'll see, players on the ice or not, or whether they are, whether you're home or away, those sorts of things. So the statistical model here that we can use is adjusting for this context. And so the outcome here, the model is going to be some sort of average effect, home ice, all the players who are on the ice, both for and against. Did you have a shift that started outside of the neutral zone, and was there some sort of score effects? What I'm going to show you is actually stuff that is not public. Actually, I haven't actually shared this and made it public, but we've been working on it, and it's lots of fun. So it is kind of a big data approach. We have 97,000 Fenwick events and 130,000 Corsi events per season. We've got about 1,200 players. This is based on initially some work that I did with a student, Jim Curo, and Jake Hurlbut, who's going to graduate in May, helped with a little bit last summer. For anybody technically inclined, we're doing a somewhat sophisticated ridge regression to deal with the multi-collinearity of what's going on. So with that said, what we get in terms of top players for an adjusted Fenwick, and I'll talk in a second about why I like Fenwick. I've got 3 years of data. So we have the players and their position. We have counts, which was how many Fenwick events they were on the ice for this, we'll call it 2.6 seasons, because we have the lockout shortened season in the middle. And then we get what was their adjusted Fenwick. So dealing with all these other factors in the model, what is their individual impact as much as we can tease out. And so this is even strength. We have a more sophisticated model that actually looks at all events, and that includes a bunch more terms, and it's a very, very long model because we deal with 5-on-4 versus 5-on-3 and zone starts on the power play, et cetera. Just point out that I'll take one player here, Justin Williams. So what we're saying is accounting for all of the other factors and all the context for which Justin Williams is on the ice. When he steps on the ice, he's adding about 3.7% to the Fenwick of his team when he does that. And we can see some of the players that we've seen before. Datsuk, Joe Thornton has showed up a couple of times. Ante Kopitar is going to show up a bunch. So, yeah. So, what we can glean from this model, the change from where a shift starts. So, moving from the neutral zone to the offensive zone is worth about 4%. The top players were worth about 4%. Home team gets you about 2%. So, automatically, you would expect the home team getting about 52%. If you're moving as you increase your score effect, you're likely to be decreasing for each goal that you score your Fenwick by about 1%. And really, in terms of these results, they tend to apply whether we do adjusted Corsi or adjusted Fenwick. We're roughly getting the same order of magnitude results there. Here's where I say that I prefer the adjusted Fenwick here. While Corsi has larger sample size when you're dealing with an individual, when we get to these large data sets, what we're really seeing is that when I look at 1 year sample and I fit the model, and then I do and try to predict what sort of ratings I'm going to get for a completely different set of models, what we're going to call an out of sample, so a completely different year and a completely different evaluation. we're seeing that the adjusted Fenwick is giving us a higher correlation than the adjusted Corsi there. And so we might even suggest that that might have something to do with the fact that blocks is in the model for Corsi and that those may really be primarily noise. The more sophisticated model that we put out there, and this is the total hockey ratings, is roughly the same model at even strength, but what we've got there for a response is a net probability of the home team scoring minus the away team scoring. Now we're at 250,000 events per season, same number of players. Just mentioned that when Jim and I originally did this, one season would take about 8 or 10 hours to run, just in terms of analysis. Jake worked his computer science magic, and we're now down to about half an hour, which is pretty awesome. A little bit more details. We assign every event, so every event that we saw in that play-by-play file for the Toronto-Boston, we assign every event like that what we call a net probability, but probability that the home goal is scored in the next 20 seconds minus probably away team scores in 20 seconds. We do a little something special with penalties. We do something with shots where we give the value of a shot is the probability that the shot goes in plus what happens in the next 20 seconds to account for rebounds, et cetera. And then we've got also not just even strength, but we've got all events there. Just to give you a sense of what is the value of particular plays, this is sort of an average value for shots because we actually use the location of shots there in terms of assigning value. You can see the value is the NP20 on the far right. And so I'll just point out to you, hit by the home team in their defensive zone, which is the very last row, actually has negative value. And that is because if you're hitting in your defensive zone, it means it's likely the other team has possession in my zone. And so therefore you can have events that lead to negative values there. And we do find that hits in the neutral zone or in your defensive zone do have negative value in this assessment. We'll look at some of the top players here, and a lot of the names will look familiar. We've got Kopitar here as the top. Again, even strength for the last 2.6 years or so. The way that we do this is we take that goal differential per event. We multiply by the events that they're on the ice, and that gives me the number of goals. We divide that by 6, and that gives me the number of wins. So back to our goal differential that we started with a long time ago. And so, you know, what we're saying here with Kopitar is over 2.6 seasons, he was worth just over 13 wins to his team. And you might think that that's, in wins, about $26 million of value that he's adding to a team if we do $2 million per win. Next slide has, it might say even strength at the top, but if not, it's all events. And so Kopitar adds about 6.5 wins on the power play, penalty kill, on the special teams there, to where it's got about 20 wins of value. And again, we can see some of the other players that we've seen before, Thornton and Bergeron as well. Now note that what we don't give credit for here is shooting percentage. And so what we're assuming is that every shot counts the same minus its location. And so we're not giving credit, say, a Sidney Crosby or an Alex Ovechkin who scores and shoots at a high percentage, not getting full credit here. And so we're working on incorporating that into the model. I mentioned here that we like Fenwick better than Corsi, but if I look at Fenwick versus this total hockey rating does at least as well at even strength, but we certainly do better there in terms of our out-of-sample correlation being almost 0.8 when we've got all events in there. So Fenwick does a little bit better in terms of validity, in terms of predicting wins, but the Thor does better in terms of predicting out-of-sample performance.
Oh, we've got about 10 minutes.
10 minutes?
Yeah.
Will we have time for questions? Or should you want to move quickly so that we've got time for questions?
I think that we can move quickly through the rest of the slides, and then we'll save a few minutes for questions at the end.
Super. Great. So we mentioned earlier rating goalies. And so one of my favorite slides here is to talk about this. If we look at overall save percentage, we'd say goalie A is everybody's favorite goalie. But if we say, well, if I just look at how they do on hard shots, well, I'd take goalie B. And if I look at just how they do on easy shots, then I would take goalie B. And so we've got this dilemma that if really we have hard shots, easy shots, and that's simplifying everything very much, right, that we get this sort of issue that save percentage is a function of two things, the difficulty of the shots you face, and then the quality of the goalie. So we can fix this, right, by creating an adjusted save percentage that accounts for difficulty of shots. What I've done here with the shot counts, which are those numbers in parentheses, is I've made the shot counts the same, and so that gives us an adjusted here. And as I mentioned, quality of shots not mattering very much. It's been the case that most of the folks who've done adjusted save percentage, it has not done well in sort of out-of-sample prediction. And so therefore it hasn't been done much because I think belief in that average quality of shots not having much of an impact. So I think that's an open area. The question was brought up earlier about the defense independent goalie rating, essentially doing the exact same thing we just did in the very simple example, but we are normalizing this time for X and Y locations, shot type as well. And so we get that sort of adjusted save percentage across. And here I've given you an example here of shots that we would look at. So from the blue line to the red line for Marc-Andre Fleury for a season, and that's a couple of years ago. I've stopped doing the rating and putting it out regularly, again, because of the issues with the X and Y coordinates and how much trust is there. Been thinking about some things, and I think it's possibly, as I mentioned at the bottom of the slide, possibly time to revisit that because I think we've got some better adjustments that may make that more reliable. So a couple of recaps there, sort of 6 sort of take-homes. And we've seen those, the value of a goal, Corsi and Fenwick, PDO, context matters. We can build some models that can do that and can account for it. The shot quality tends to be a small factor. I've got one more slide of content. And this is other things we didn't have time, and I'm happy to take questions. But teams should pull the goalie more. I mentioned drawing penalties seems to be repeatable. There's a whole body of work on difference between an average player and what might be considered a replacement. The referees actually do a great job, at least in one small study we did. We've done some work on draft selection and what the value of a draft pick might be. Actually, Central Scouting does a pretty good job, though they can be beat. We've done some work on face-offs. Shootouts tend to be very, very random things. And there's a whole body of work on, if I know someone is in the AHL this year, what would I predict for them to do next year? So it's what are called league translations in how do I translate some value there. Also happy to announce that we've got a new major in statistics coming up, and so the faculty just approved that. And it's been endorsed by the Board of Trustees, and we're waiting on New York State. And then the last slide with any content here is a link to some of the stuff that we've done. Got an index there of papers, and then an index of hockey postings. It's not the most active of blogs, because I tend to do things that end up being 2 or 3 pages at a time. But there are some things there if you'd like some further reading. And there's my email. I'm happy to take questions. I've got Twitter. And those are a list of St. Lawrence faculty and students who have helped with projects along the way. So I'll be happy to take questions.
All right, great. Again, if you have a question or comment, raise your hand or go ahead and type your question in. So I'm just going to scroll through here. Looks like we've got some questions. So here's a question from Joshua. It says, do any players have negative Fenwick as an individual?
Yes. So it's not possible to have a negative Fenwick. It is certainly possible to have a negative adjusted Fenwick. And in fact, someone has just posted, he just called him a Clarkson player. I can laugh at that a little bit. I must admit to being married to a Clarkson faculty member, so I have to watch myself a little bit. Certainly in terms of adjusted Fenwick, we do see some players like that, and I had a conversation with an NHL team about 2 weeks ago, or someone from an NHL team, and they were complaining about one of their defensemen and the analytics community not liking the particular defenseman, in part because this player's Fenwick was not particularly good, but the coaches love the player. When the scouts watch the player, they're very happy. It turns out to be one of these sort of big data things that if you watch with your eyes, you can't fully process and make a sense of all of the things that are going on and all those contextual factors.
A question from Matthew Whitehead says, what effect does officiating have on the analytics?
I would say in hockey, we don't know the answer to that. I would say that is something. The study that I did on referees looked at the rate of penalty calling among referees, and they were remarkably consistent. And so I've used the term robot there, but I think across there's certainly going to be questionable calls, but I think over the course of a season, the rate of penalty calling among the refs is remarkably similar.
Okay, Rick Hutchins says, does any NHL team keep track of the percentage of time that they score when they've pulled their goalie and the percentage of time that they are scored upon after pulling their goalie? Where are these stats, if available?
I have to assume that NHL teams track that sort of thing. NHL.com probably has some sort of summary where that might be available. A couple of the other sites that are linked that I've given you, if you send me an email, I can probably point you and find a page where that might be available.
Okay, you might have touched on this one a little bit, but here's a question from Jeremy. I might not.
So Tuukka Rask won the Vezina Trophy last year, yet Carey Price outplayed them when they beat Boston in the playoffs. Do you think statistics for goalies need to be reevaluated? So I do think that the additional information and the tracking information that potentially we have will change our viewpoint of goalies and of defense more than they'll change our tracking of offense.
Okay. Here's another question. It says, you mentioned screened shots earlier. On a related note, has anyone looked at the scoring percentage of deflections versus clean shots?
So in the NHL data, we do have a category, at least the NHL records a category for tips or deflections. The issue would be most of those tips or deflections are only recorded if it's a goal and not very much recorded for a shot. That is, one player takes a shot and another tips it. It is unclear where the NHL or where any particular rink would give the credit for that.
A question from Bruce Carlisle. Bruce is asking, have you ever looked at your predictions for outcomes versus Las Vegas betting lines? Who wins?
I haven't done it. I've certainly thought about doing it. I actually looked in the last 10 days at what some of the Vegas lines look like for teams winning the Stanley Cup. And I would certainly say I think there are some teams that are overvalued. I think Pittsburgh is overvalued. I think the odds for Pittsburgh winning the Stanley Cup are much lower in Vegas than they probably would be from most analytics perspectives.
Great. Another question from Rajiv. He's saying, can we use this kind of predictive model approach in other sports like soccer?
Yeah, I would say that soccer is probably even a little bit ahead of hockey in the use of these methods. Soccer has started to use the player tracking, and I just saw a nice presentation at a conference in Boston a month or two ago where they're using some of that player tracking information to evaluate quality of chances. And things like what is the speed of the attack, what is the formation of the attack, and how does that have an impact on whether or not a goal is scored.
Okay, we have another question from Matthew. What's your opinion of plus and minus ratings?
So I was on a panel with Brian Burke and Mike Milbury a couple of years ago, and Brian Burke goaded me into using a swear word to describe plus-minus ratings. I won't do that again, but I will say just in terms of the raw plus-minus that you would see, those are much more team measures than they are player measures, and that ideally you've got to take those with the context that they're in.
A question from Seth Jackson. Seth is saying, will this analytics revolution bring unwatchable 76ers type franchise overhauls to the NHL?
I think not, for a couple of reasons. I think that the depth of any one draft in the NBA is small, and so the advantages for a 76ers type approach is much higher in the NBA, because I think the drop-off from, say, the first player taking the draft to the 10th is much larger in basketball than it is in the NHL.
Lots of great questions that keep coming in. So we've got another one here from Matthew. He said, if scoring is a combination of getting into good spots and shooting ability, Chris Boyle has looked at the ability of players to get into better locations. Do you have any idea of how to account for the player's physical shooting ability?
So the way to do that, I think, would be to get information on location of shots that they're taking, and then look at the outcomes that they're getting and adjust, look at what is a league average. So you could get an adjusted shooting percentage in much the same way you did an adjusted save percentage. And so you could look at that and extract that, and I actually think that there are a couple of people who have tried to do it. You mentioned Chris Boyle. A lot of what Chris has done is very time-consuming because he's actually watching every single shot and recording by hand. And so he's ended up, I think, not getting complete data sets, and that's sort of the trade-off between automated versus by hand.
Here's a question from Jordan Paley. Jordan asks, with the different boards and ice in the arenas, how much of a difference does it make in Fenwick?
That is, I guess, a question I don't have an answer to. I can tell you in terms of recording of Fenwick, there are some rinks that record it differently, and we've adjusted for the quality of the teams playing. But to get at what the actual ice and boards impact, that would be hard. It would probably require measurement and knowledge of when boards were changing and quality of ice maybe on a given night. So that would be a real challenge.
It looks like we've answered all of the questions that we have, but certainly if other questions come to mind after the webinar tonight, as Michael said, please feel free to reach out to him to continue to ask those questions. I just want to say a special thank you to Dr. Schuckers for being willing to lead tonight's online Laurentian lecture, and thanks to all of you for calling in and being online to participate. Just wanted to let you know that when the webinar concludes tonight, you'll have a pop-up on your screen to invite you to answer a few questions. I would invite you to take a few moments to complete the survey. It gives you an opportunity to share ideas that you have for future topics or faculty that you'd like to hear from. So, Michael, is there anything that you want to say in conclusion before we end?
No, thanks. Been lots of fun and lots of great questions. And yeah, if you have other questions that come up later, I'm happy to answer those. Feel free to send me an email.
All right. Good night, everyone. Thanks so much.